All free-falling objects have a constant acceleration. On Earth, the acceleration due to gravity is negative 9.8 meters per second squared. Looking at the following examples, we can see that this is the case.
Go.
When we see these two balls, the tennis ball on the left and the lacrosse ball on the right, drop, they hit the ground at the same time despite their varying masses. This is due to the discovery by Galileo stating that all objects fall at the same acceleration, no matter if their mass is large or small. We can see this as we compare a tennis ball in free fall to a basketball. First, let's look at the tennis ball.
Go.
When the y velocity is plotted against time, we can find the slope, which turns out to be negative 9.8 meters per second squared. Now let's look at the basketball.
Go.
Note that despite the varying size and mass, the slope is the same, meaning that the basketball's acceleration is also negative 9.8 meters per second squared. This proves Galileo's findings that all objects in free fall have a constant and uniform acceleration. So what happens if instead of just dropping the ball, we throw it? Is it still in free fall despite this extra force? Let's look at the tennis ball to see.
Go.
As you can see by the graph, acceleration does not change. Once the ball leaves the person's hand, the object is in free fall and accelerates at negative 9.8 meters per second squared. The only thing that has changed is the object's initial velocity.
If one ball is thrown and the other is simply dropped, although the velocities are different, the accelerations will still be the same.
Therefore, no matter what you drop at the same time, they will fall at the same rate if you negate any external forces, such as air resistance. A popular example of this is when Neil Armstrong dropped a feather at the same time as a hammer went on the moon, and they reached the ground at the same time. You would think the feather would take longer, but it doesn't in the absence of air resistance. In conclusion, on Earth, all objects in free fall have a uniform acceleration of 9.8 meters per second squared.